Hey guys, welcome back. Welcome back to Herb's class in 5-minute math. Today we're going further down this normal distribution path to talk about inverse normal distribution. Okay, so the normal distribution problems that we have done so far, we have been given a data value or data values, and we have been asked to find the probability or percentage. So when you are given the data value and asked to find the probability or percentage, we use the normal CDF or normal PDF functions on our calculator. So now, what if the problem is reversed? What if we are asked to find the data value and they give us the probability? In essence, what if they ask us to do the problem in reverse? Instead of using the normal CDF, if we are given the probability and asked to find data values, we're going to use what's called the inverse normal. So our calculators are going to do this for us, but let's run through a couple of problems. Okay, so I have a problem here. We have discussed already how to do 3A parts 1 and 2. Here we are given data values and we are asked for a probability. So we would use our normal CDF function to find that. Now, for part B, determine the weight. So now they're asking us for a data value and they are giving us a percentage. Now remember, that percentage can also be a probability. 75% as a probability would be, of course, 0.75. So we're gonna start this out like we normally would with a picture. Here's a picture of our normal distribution curve. Now on this picture for part B, we don't know what the actual data value is. So what we're gonna do is we're just gonna put one on here. Bang. That's gonna be our data value X. Now, we are going to determine what this data value is. Actually, it's a weight. So maybe I'll change that X to a W. W, good. Okay, so it says determine the weight exceeded by 75% of the bags. That means that this weight is exceeded by 75% of the bags. So is that 75% going to be above this weight, or is that 75% going to be below this weight? Now, that's one of the things that you have to figure out in these problems. You will have to translate this vocabulary to determine which side of the line 75% is on. So if this weight is exceeded means more than, 75% of the bags weigh more than this. So if I was to ask you which side the 75% is on, bang, the right-hand side of that line. These are where the values greater than W are. Now, for this particular problem, for normal distribution, we do not use percentages. So change that percentage into a decimal. Bang, just like that. Now, if the area under this entire curve is 1, so if 75% is on this side of the line, then how many percent or what probability would be on the other side of the line? Oh yeah, 0.25. 75% of the data is greater than W and 25% of the data is less than W. So we are going to use these values in our inverse normal calculations. So to the calculator we go. Before we go to the calculator, we should discuss a rule. When you are working with inverse normal, this will apply when we get to the calculator, but when you are using inverse normal, you use the left side probability. So the problem will not always give that to you. Sometimes you have to find it. Case in point, 75%, that was on the right side of our value. So we need to subtract that from 1 to get the left side probability. Okay, to the calculator. So we're gonna work with Casio first. Then on this Casio, do you remember how to get to inverse normal? All right, let's do it. Let's turn it on first. There we go. So let's get to our menu. We are going to statistics, distribution, which is under F5, normal, which is under F1. Now this is where we pick our normal PDF or normal CDF, but look what we have third here, inverse normal. So let's go ahead and click on that, inverse normal. Make sure your data says variable, make sure your tail says left because we're looking for the left side probability. Now in here it says area. This area means the probability on the left side of this data line. What was our probability on the left side of that line? Yeah, exactly right, 0.25. So let's go down here and put 0.25. And then it's asking for the same variables as before. This is, of course, is our standard deviation according to the problem, 0.5. And our mean, according to the problem, 25.8. Good. Go ahead and calculate the data value that we are looking for. Bang, 25.5 kilograms. So if this weight is 25.5 kilograms, 75% of the bags weigh more than that. And 25% of the bags weigh less than that. Don't forget, this is huge. Use the left side probability. Okay, so let me show you how to do that on a TI, and then we are good to go. Switching calculators. Bang, here we go with the TI. Same thing, inverse normal. Now remember on the TI to get the distribution, second vars. Distribution, as you can see, normal PDF, normal CDF, and what's third? Inverse normal. Now, for a TI, you have to put it in a particular order. Okay, so for the TI, inverse normal requires the variables to be put in a certain order. We put the left side area first, always the left side area. So 0.25, comma, and then the mean, and then the standard deviation. The mean was 25.8, comma, standard deviation 0.5. Bang, and look what we get, 25.5 kilograms. Nice. Now, pay close attention to the way the problem is worded. Sometimes you will be given the left side area already. Sometimes you will be given the right side area, and then you'll have to subtract that probability from 1 to find the left side area. It all depends on how the problem is worded. All right, hopefully this helps. I'll see you next time, y'all.